Good morning. This is Manoj in front of you. I am from cybersecurity, and today we have to discuss about the topics are cluster computing, grid computing, and biocomputing on cloud computing. So, first of all, we have to see what is meant by cluster computing. Okay, so cluster computing is nothing but we are going to dividing a large amount of data in a single unit and performing a specific task. So here the definition of cluster computing is it is a form of distributed computing where multiple computers referred to as nodes are connecting via the high speed internet and work together as a single unified systems. The primary goal is to providing high performance, reliability, scalability for computational tasks by processing power and resources of the nodes. So here we have to say that a cluster computing is nothing but a large amount of data are going to distributing in parallel to all the systems over the network, and the data which we are going to communicate in the nodes are going to take in a procedure form and reverse back to the primary or master node. So here the cluster computing will be distributing in a way that parallelized the data is going to distribute over the network of nodes. So let us see the structure. So here the cluster computing will be used to take the input data to the root node. This root node is going to take the data from the input from or a customer, and the data is going to distribute to the n number of nodes over the network. So here as for this figure, you have to see that n number of nodes on the network is going to divided by this root node. Means the root node is going to take the data from the higher authority or a customer, and he is going to distributing the data or distributing this information to the n number of nodes, that is in a slave nodes, and this n number of nodes are going to take the data from the root node, and he is going to take performance, and he is going to take and performance and give the data back to the root node. This root node is going to performing all check the all the data on the root nodes and in the root nodes, and he is going to give the report to the end users like in a result. So as for the figure, you have to see that. So let us see the master node. See here, this is the master node, we can say is a root node. This root node responsibilities are we are receiving the input data from the higher authority, and in the same way it is going to dividing the task into the subtask to the sub nodes, and the distributing the subtask to the slave nodes. We can say this is the slave nodes. Okay, so slave nodes is going to take the data from the root node and in a parallel way to distributing the data, and the slave nodes are collecting and combining the result in a slave nodes. Means here they are going to performing some task with the help of an methods, and he is going to take the report from the higher authority, and he is going to distributing the data to the root node. Okay, so the slave nodes is going to take what are the responsibilities are going to take here, the nodes that performing the computational assigned by the master. Okay, so they are work on a specific subtask and send the result back to the master node. So here this slave node is going to take the data from the root node. The root node is going to dividing parallel to the all the subnodes on a network. This subnodes or slave nodes are going to take the data from the master node, and he is going to take a performance on the data, and finally the data is going to the resulted data is going to back to the master node. So here the input data is nothing but a we can say the data or a problem is initially provided by the master node for processing. Means we are going to take the data from the higher authority like in a client. So the data is going to take from the client or in a higher authority, and he is going to take the responsibility to distributing the data to the all the cluster nodes, or we can say the slave nodes. These slave nodes are going to take the data, and he is going to performing the professional task here, and he is going to give the accurate result to the end to the back to the root node. So the aggregation means here the master node aggregation result from the slave node and produce a final report. So the here you can see the final report means all the data output data all the output data on the slave nodes. So output data of the slave nodes are going to take back to the master node or a root node. This root node are going to take the resulting analysis, and he is going to send the final report as in a back to the network. So that is called resultant. That then we can say it is in a cluster node. Cluster is nothing but a individual data or a large amount of data is going to distributing in a parallel manner to the all the nodes over the network, and easily it can perform a single unit. We can say single unit. So unified systems means all the data is going to distribute in a distributed in a parallel over the slave nodes on the network, and they can perform in a single node. That is called cluster node. So next one is grid computing. Okay, grid is nothing but same like in a cluster, but here the grid is going to performing a individual task. Grid is going to perform an individual task, and they can use the data in a parallel distributing way to all the nodes over the network, and it will be used to distributed, it will used to save the data on a network like that. So see here, distributed computing, grid computing is a distributed computing paradigm where resources are multiple, often geographically disparate. The computing systems are pooled together to work a collaborative on a large scale task. Means here collaborative means here over the network, grid is an individual unit or individual node. Here the grid is an individual unit or individual node. They can performing a individual task, but here they are going to distributing in a proper way over the network, and is going to save the data to the central node. We can say it is a central or master node. Okay, say the data to the master node means same like in a cluster computing, but here we are going to performing an individual task on an individual geographical area, and all together to form a unit, single unit. Then you could say it is a grid computing. So after that, those systems which are including personal computers, servers, or even supercomputers are connecting over the network, such as the internet, and work towards as a common goal, sharing computing powers, data, storage, and other resources. So here we can say individual unit or individual node can performing this individual task, and the task after the completion of the aggregation result, they are going to send back to the master node or a master server over the network. So that in this way the grid computing is going to performing on a cloud. So let us see this grid computing infra architecture. Okay, how they are going to performing. This is a central node says individual nodes. Okay, central nodes, and these are the individual nodes. The individual nodes can take the report or take the data from the authority, and he is going to perform an individual task on individual unit way, and the data is going to say to the end user like in a central node. Okay, in the same way all the connectivity over the network, all the connectivity nodes over the network are taken up individual task, and the task is going to send back to the server. So we can say individual tasks are going to performing in a grid computing, and they can form a single unit. So like that. So first of all, see the here central coordinator means central coordinator is nothing but a central node. This central node act as an hub or a mass managing as in a grid. So this responsibility is accepting task from the users. First of all, they are going to take the data from the users and dividing the task into small subtasks and distributing subtasks to the connecting nodes. So aggregation results from the nodes to generating a final report. Like this all are going to performing like in a cluster computing. Same like we are going to take the data from the higher authority or a user. Okay, and the data is going to distributing in a parallel way to the end nodes which are connecting over the network. They are going to performing a task over there, and he is going to take the result from the slave nodes. So final report. Okay, so same like that, but here the grid computing is nothing but a individual computer. In the cluster computing is nothing but a all the data is going to come and to form a single unit, that is called cluster. But here individual like a desktop servers or clusters or individual units are going to performing the same task or different tasks, and the aggregation result back sent back to the master node. So the individual systems that contributing those computational resources to the grid. So each node independently processing the assigned subtask and communication results back to the control node. So here we are going to take the report from the slave nodes, and his back and the data is going to send back to the master nodes. So here everything is going to stored in a master node. So we are going to connecting with the help of an internet. So that's why network infrastructure most important in any computing. Network is a master point here in any computing resources, like enabling communication between control nodes and grid nodes. So we can connect local area network, wild area network, or internet. So here internet is most important material, or sorry, most important connectivity to communicate over the network to all the remaining nodes. Okay, so this without internet we cannot communicate, or we cannot access the cloud data on a network. Okay, so that is called grid computing. Next one is biocomputing. Biocomputing or a biological computing, it is an interdisciplinary field that combines biological, computer science and engineering to leverage biological systems for computational tasks. It involves the use of biological molecules like DNA or RNA, means single neural network or a double neural network. Double neural network or single neural network or protons or living organizations such as cells to process information, performing computational and solve complex problems. So here biocomputing, which are mainly we are going to use in the biocomputing in the cloud computing, is that we are going to take the accurate result from the living organization in a proper way. Accurate result from the living organization in a proper way. So that's why we are going to use the biocomputing or biological computing. Okay, so this is the architecture or applications which we have to use in the biocomputing. The first one is smart therapeutics, and the next one is hybrid bioelectronic devices. Next one is biomedicine, environmental science, sensing devices, and material science. These are the 5 applications which we have to use in the biocomputing or biological computing. The first one is smart therapy. So therapy is nothing but we are going to detect the diseases. We are going to detect the diseases with the help of a smart therapy. So here development or a programmable therapeutic agents that can detect and responding to a specific biological condition in a real time, means we are going to find out the any diseases with the help of this therapy. Means here we are going DNA, means double neural algorithm or analysis based nanobots for targeting drug delivery. In the same way, single neural based therapies are gene silencing, which are RNA interfaces to treating generic disorders. See here, disorders means these smart therapies which we are going to use to find out the diseases of a living organization in a proper way to give the aggregation result on a pure or resulting proper way. That is called smart therapies. Okay, so next one we are going to use the applications are cancer treatments, chronic diseases management, and precision medicines. Means we based on that diseases we are going to find out in the smart therapy. We have to find the applications, or we are going to say the controls on the therapy. So means controls on the diseases based on the medicines. So next one, hybrid bioelectronic device. Hybrid bioelectronic devices nothing but a electronic circuits. Without using any electronic circuits, some of the bioelectronic devices are not going to work, are not going to give the results. Like example, bioelectronic sensing, glucose monitoring. We are used to glucose monitoring on a bioelectronic in the neural implants for interfacing with brains and spiral cords. Means we are going to find out the any diseases. After the diseases find out, we are going to continuously monitoring based on these bioelectronic devices, continuously monitoring about the results, not in a result. Continuously we are going to monitoring the diseases on a living organization. We are going to use the applications like brain computer interfaces or medical diagnosis. Means medical diagnosis, you know that we are going to diagnosis, we are going to take the reports from any medical center, and based on the diagnosis, we have to take the application, or we have to take the medicines on based on the diagnosis, right? So that's why we are going to use hybrid bioelectronic device. Means bioelectronic device, based on the bioelectronic devices, we are easily find out the diseases based on this electronic circuits. Next one is medicines. So here, based on that, medicines, use of biological computing for advancing in medical science, particularly in understanding, diagnosing and treating diseases. We have to use after the diagnosis, we have to take the precautions based on the diagnosis, and we have to continuously take the medicines, right? So that's biomedicines with modeling complex biological pathway using computational tools, simulating drug interaction with molecular structure. So here we are going to use the drug discovery or a personalized medicines or a generic engineering based on this bioelectronic medicines are going to use here. So based on that, we are going to identify any disease and any disorders in the living organisms with the help of a therapy, and we have to find out some bioelectronic devices with a diagnosis of the therapy or diseases. After that, we are going to use the medicine of that diseases or based on the diagnosis. Next, we are going to use environmental sensing devices. So sensing devices is nothing but we have to sense any motion, or we have to sense any uh, type of detecting environment storage. So here we are going to easily identify any molecules or any fungus are going to enter into this particular secure area. Like biocomputing techniques are applied to create sensing that can detect environmental changes or pollutant with high sensitivity. Okay, so here the examples are engineered bacteria that fluoresce in the presence of heavy materials, DNA-based biosensor for detecting waterborne pathogens. So here we are going to identify the any sensing devices like bacteria are going to enter into this particular area. So here we are going to easily identify based on this environmental sensing device. Means any fungus or any wave or unwatered control molecules are going to enter into the particular area or not. So here based on the applications, we are going to use that environmental monitoring, pollution controls and ecosystem management. So we are going to use to protect the particular area with the help of a living organism which we are going to live there. We have to use the diagnosis of that, and continuously we have to give the medicine based on the monitoring, and we have to use the environment says any fungus or bacteria is going to enter into this particular area or not. Okay, next and the last one is material science. So material science is nothing but we are going to use the biocomputing approaches to design and develop new materials inspired by a biological process. Means we are going to use any new technology to find out or discover the diseases easily, and easily we are going to diagnose the content of living organism in a proper way to monitoring or not. So we are use the potential based nanostructure for advanced materials. Means we are going to use to find out an advanced material to find out any diseases or diagnosis of the content of the living organism. DNA origami technologies to create nanoscales materials. So here we are going to use to nano means micro scaling materials are going to use to find out any diseases are going to occur into the particular living organism. So we are going to use the applications are nanotechnology, bio-inspired materials and engineering storage systems. These are the applications which we have to use to find out any diseases with the help of a diagnosis, and continuously we are going to use the monitoring to be in a biomedicines, and finally we are going to use to sensing the device on an environmental way securely. Okay, so these are the references which we have to use for cluster computing, grid computing, biocomputing techniques. Okay, thank you.